Okay, so we are going to find the equation of the line that goes through these 2 points. So I took the liberty of grabbing these 2 points, and it looks marvelous, but my line's kind of crooked. Don't judge. Okay, so when you write the equation of a line, it looks like this. Okay, now let's talk about this real quick. The M stands for the slope, okay? Now the slope, remember, it's how far up we go and down, up or down, and how far over we go. So we usually write it like y over x. We also call it the rate of change, or the ROC, the rock. And then we've got this part, which is our y-intercept, okay? And that's usually where it crosses on your y-axis. Now, I'm not quite sure where that crosses, so we're just going to leave it at that. We're going to find the equation so we know for sure where it crosses through here. Okay, now, the first thing we're going to use to find our equation, we're going to find the slope. So we're going to figure out how far up we went from this point to the next, and how far over we went. So if you think about it, I'm down here at -2, and I go all the way up to 4, and if you count that I went up 6. Okay, so I went up 6, and then I'm here at 2, and I went over to 5, so I went over 3 to the right. So because I went up 6, that's positive, and because I went right 3, that's positive. So I'm going to say my slope, I went up 6 and I went to the right 3. Now, I can reduce that, but I'm not going to yet. Okay? I could reduce it, but I'm not going to yet. Now, check this out. I'm going to talk about how I got the 6 again. If you look at that close, I took the difference between -2 and 4. The difference, like the distance between the two. So from 2 to 4, or sorry, -2 to 4 is 6 notches. So I could say it's the difference between -2 and 4. Difference meaning I minused them. And if you think about it, then I took the difference between, let's see, I took the difference between 2 and 5. Okay, so the difference between 2 and 5, so I went like this. I went 2, and if you minus 5, that should get it for you. Now, I just want you to double check my work here. -2 minus 4, that's actually -6. And 2 minus 5 is -3. But you see how a negative over a negative still came out positive, so I'm okay. Now, this is how you can always find the slope. You can take, now if you look, I took the 2 y's and I minused them. And then I took the 2 x's and I minused them. So now, I'm not always going to be minusing these two numbers. So I'm just going to call one, let's see, the -2, I'm just going to call it y2. And the other y, I'm going to call y1. Because they might not always be those numbers. And these x's might not always be these x's, so I'm going to call them, x2 and x1. Okay, so I'm going to put those down here. So instead of those 2 y's, whatever y's I've got, I'm going to find the difference between them. And the x's, I'm just going to find the difference between those. So this formula right here will help you find that slope between any 2 points you want. So I'm going to take this formula and I'm going to rewrite it down here over x2 minus x1. Now, I'm going to do some moving around with this formula, okay? And I'm going to use this formula to help me write this line, so check this out. I want to move this whole thing down here. Do you remember how to move that whole thing? If it's being divided, we got to multiply it. So I'm going to multiply it on both sides. You got to do it to both sides. Okay, so I multiplied on both sides. Here, they're gone. So I'm going to write it like this. Oh, sorry, I don't write very well. Now, is it okay if I switch those around? It's getting multiplied anyway. That's the commutative property. It lets me do that. Okay, so here we go. So do you see how I moved that? Now, I want this to be over here and this to be over here. So I'm just going to switch this around like this. So I've got y2 minus y1 equals the m and x2 minus x1. Okay, now that formula right there, this one right here, this is going to help us find our line equation. So I'm going to plug in the slope of what I found, and we can reduce that now. We'll call it 2, because that's what 6 divided by 3 is. Okay, we're going to call that 2, so I'm going to plug that in here for the m. Now, I want to keep one of these as y and x, because in a line equation, we have an x and we have a y, so I'm not going to fill them both in. I'm just going to pick one of these points, I don't care which one, and we're going to plug it in. I'm going to use that one. Okay, I'm going to plug that in for x2 and that in for y2. So let's see, the y2 was -2. So I'm going to say -2. Now I'm going to keep that as a y. I'm not going to change that. Okay, I'm going to leave it. And my m, my slope was 2, so I'm going to plug that in. And put my parentheses, so my x2 was a 2. Okay. And I'm going to leave that x1 there. Okay, now, here we go. Now that might look a little confusing, but let's just keep going with it. So here we go. -2 minus y1 equals, now we're going to use the distributive property. We're going to times through, so 2 times 2 is 4. And 2 times -x is -2x. 1. Now, you really don't need the ones there, because if you look at this equation, it just has a y and an x. So if you want to, you don't have to write those little ones. So I'm going to get rid of them. Okay, we don't need them. So I'm going to rewrite this now. -2 minus y equals 4 minus 2x. Okay, look, it's getting really close to how it's supposed to look. So I'm going to move this. I'm going to add that to both sides. So now I've got this, -y equals, add those, and bring the -2x down. Now, there's a negative there. I want it just a plain old y, so I'm going to times this both sides by -1, and everything over here by -1. So a negative times a negative is a positive. So -1 times 6 is -6, and -1 times -2 is +2. So check that out, everybody. We did it. So now here's my equation. I'm going to move those around. So I got 2x and a -6. So there is my line equation. So let's double check it up here. Okay, now that's supposed to go through there. I bet if I drew that straight enough, it'd go right through. Now check this out. So my y-intercept is -6, which totally works. And then my slope. Now it should be in a fraction form, and it's not. So what can you do again? Put it over 1. So let's check. Is it up 2 and over 1? Look at that. Up 2 over 1, up 2 over 1, up 2 over 1. So it totally worked. So that's how you use a point to find that line equation. Now, I could also have used the other point. I could have plugged that in for y2 and x2, and it would have worked the same way. Anyways, but my video is already long. But if you want, I can show it the other way as well. So I'm going to do it real quick. So y minus y2 equals, now if you want I can put the ones back in, but I'm just going to leave it. Okay, so here we go. I'm going to put in this for the y2 and that for the x2. So here we go, y minus y2. So the 4 equals m, and there's the x2, it's a 5. Okay, so here we go. So there's nothing that needs to happen on that side, but check this out. Oh, what was our slope again? It was a 2. Put a 2 there. Okay, so I'm going to distribute through. So here we go. 2x, 2 times -5 is -10. Okay, we got to move the 4, so I'm going to add it here and add it here. Oh, yeah, check that out. 2x, and that added together, -cx. Bam! So either way, you get the same answer. So I plugged in that for the point, and I also used the other one. Either way works is fine, okay? And if you do it, it should work out great, and your graph should match. Anyways, so there you go.